everybody. I'm so excited to be here with you today where we can talk about how we can elevate authentication security and step things up a notch. Let's do a little bit of role playing. Let's say that you're a developer who works on an enterprise application that handles procurement. By procurement, I mean the large-scale purchasing of industrial or manufacturing goods. So something that's fairly significant. And you are awesome as a developer, meaning that your app has authentication and it uses authorization for access control measures. So people who don't have the authority to buy things can't even get into that procurement module. Let's consider the case of a buyer making a large purchase. The flow might be something like this. They might sign in for the day, they might work on a few tasks, they might go get some coffee or some lunch, and then they come back to making this transaction that is fairly significant. Is there a way that we can assure that that buyer is who they say they really are before allowing such a large transaction, so on a conditional purchase? Well, there wasn't a way to do so in a standardized manner before, but that has changed, and I can't wait to share that with you today. So what we're going to do is we're going to try to do a little bit of live coding and some live authentication action here. So hopefully everything goes OK with these live demos. But before we do so, we do need to have some shared context. So I'm going to give that to you at the highest level that I can, just the minimum, so we can dive into the code and see how this all works in action. As I said, you're such an awesome developer, which means that you're already using industry-recognized best practices for authentication and for authorization. And that is OAuth 2.0 for authorization and OpenID Connect, or OIDC, that is an authentication and identity layer built on top of OAuth. Hopefully you all had a chance to listen to Ramona's talk yesterday at the Vue.js conf about authentication patterns, and we're just going to build off of that. In a regular sign-in flow, you'll probably use something like an identity provider. This is a thing that will centralize your management of your users for you, and this is widely used by large enterprises and large organizations. Your client application would redirect the user to authenticate on a page that's hosted by that identity provider for their user consent. And in that process, we're going to pass over some parameters to the identity provider in the URL, which we will be looking at here soon. And there's going to be an exchange that happens. And at the end of it, the client application gets a hold of a couple of tokens, the ID token from the OIDC layer and the access token from the OAuth layer. Those tokens may be in JSON Web Token or JOT format. JOTs are a compact and secure way to transmit information. And they look something like this, which is a jumbled string. There's 3 parts to it, and it's dot delimited. We don't need to worry about the header and the signature for this particular talk, and we can focus on the middle section, which is the payload. Now, just because JOTs are secure doesn't mean it's confidential. So we can decode the payload and take a look at what's inside, which has metadata called claims, and it's like a key-value pair. So we'll be digging into that a little bit today as well. All right, so every time we get into one of these slides, what this means is it's time to do a little bit of coding. So in this section, we're going to tour the sample application that I created. We're going to sign in and take a look at that authentication process and explore some Angular building blocks that we're going to be using to build upon this talk. And for this talk, we're going to use the Tour of Heroes. I did not build an enterprise procurement app because that sounds like a lot of work. And plus, I wanted to make sure that we're all on the same page about the industry that we all have shared knowledge of, and not have to get into supply chain stuff and logistics and things like that. And as Angular developers, we all have really good knowledge in the industry of touring heroes, thanks to the Tour of Hero walkthrough that Angular team has put together. So the first thing we're going to do, and hopefully you all could see this, this is large enough, is look at this application that I built. It's stunning, right? A lot going on here. What we have is this Tour of Heroes site, and we have this dashboard that lists all these featured heroes. And then we can sign in. So if I press the sign in button, I'm navigated to a page that is hosted on the identity provider. In this case, I'm using Okta because I work there. I can set up an account that doesn't have any trial expiration dates or rate limits or anything. And plus, y'all get a chance to check this out yourself without having set up your own account. So I can sign in here, but I just want to call this out because I will be sharing this code with everybody. If you want to play with it, you'll need to press this little sign-up button to create your own account. The only person who will see this email is me. I'm not going to share it with marketing or anybody. So do what you will with that, but you will need to do email verification. So I'm going to sign in, and I'm going to put in a password. And I really lowered the password complexity to make it easier for a demo, so don't judge me, OK? All right, so now I signed in. Oh, and I forgot to show the URL, but I can do that here. If I go to console, and I have DevTools open, and I have reserve log enabled, so we can, here we go. So we can take a look at all the different redirects. Here, can you see this? Hopefully it's big enough. You can see where we navigated to the identity provider, and we have some parameters like that client_ID, and we have these scopes and things like that. So we're going to be looking at that here a little bit later. So those are those URL parameters that we're passing in. Once we're authenticated, we have a couple of routes now available to us. We can go to the heroes route, where we see a list of hero details. And it is making a call out to a backend API. And then on the admin dashboard, I don't have anything in there, but this is where we might house extra sensitive actions like that procurement section. So with that very quick tour of that Heroes application, I want to dive into the code. What we'll be working with is an Angular front end with a Nest.js backend on a Learner mono repo, trying to keep this really, really minimal. I've also already added all of the authentication configuration that is required, and also calls out and gets the configurations for connecting with Okta, which you will have also in the sample repo that I share. If we take a look at the routes, you see that I have just a few, and I use the can activate guard to make sure that a user is authenticated before allowing them to continue to the admin route and the heroes route. And I'm using an interceptor to add the access token to make that call to get that list of heroes. So this is some of the context that we'll need and that we'll be working upon. And I'll show you what that looks like in the network tab. And then lastly, I have an auth service that wraps a lot of the Angular SDK calls from Okta to do authentication and to get information that we need. I'm doing this so that we can focus on the parts that's really pertinent for this talk and not have to worry about the details of using any particular API. And I want to call out that just because I'm using Okta here doesn't mean that this is only an Okta thing. This is actually something that would be applicable to broadly to other identity providers, whatever you use. So just so you see this, if we take a look at the network tab, I had made this call to heroes, and I'm passing that access token in the authorization header. So interceptor works as expected. All right, let's get back into having a user identity assurances. So how do we know that that buyer is really who they say they are upon a really large purchase? We can do this now with a new OAuth 2.0 extension method. It's a specification called the Step-Up Authentication Challenge. This spec is fairly new. It came out and published last October, so it's about a year old now. But spec processes take a long time to work through the system, so you might have heard about this before. But the awesome thing about this spec is that it allows us to elevate authentication factors, and it also allows us to enforce recency of authentication in a standardized format. How this works is your client application can conditionally send the user back to sign in on that authentication page from your identity provider and request a stepped-up authentication level. And it does this using a particular claim in the JOT. It's called the Authentication Context Class Reference, or ACR claim. And the ACR claim defines business rules that are required for identifying levels of the assurance profiles. Now, I want to call out, this is a business rule for identifying the user assurances. It's not the authentication method, right? And you'll see what I mean here in a little bit. And we'll see this in two different ways. We'll see the ACR claim that identifies the current level of authentication, and we're going to see ACR_values property. And this is the requested authentication level that we'll see, like in the URL, for example. If we take a look at what this looks like end to end, it will look something like this. Ready to log in. And when you do, the user is navigated to that page hosted by the identity provider, and they're presented with a username and password field, just like what we saw earlier. And now they have access to, let's say, the dashboard or something. They're now authenticated, and they have access to navigate to this admin route. When the user tries to navigate to that admin route, your client will need to check to see what the ACR value currently is in the ID token. If that value isn't high enough of a level for this resource protection, then it's going to send the user back to the identity provider and then pass in the elevated ACR value in the URL. And so now the user must authenticate using biometrics, as an example. The identity provider will issue new access and ID tokens that then your client will verify to make sure that the ACR value meets what is required for this resource, such as accessing that admin route, and so they can now continue navigation. Those ACR values could be a variety of different things. There are standard values for ACR, such as PHR or PHRH, which stands for phishing-resistant and phishing-resistant hardware factors. These would be your highest levels of assurance profiles, such as using a FIDO2 authentication device or hardware keys, passkeys, things like that. It can also be a standard schema. Like this is one that Auth0 uses for saying that it has to be multi-factor authentication level. And then lastly, you can also have custom registries, such as this one that Okta uses, saying that the level of authentication, LOA, is any two factors. If we take a look at a pseudocode of what this might look like in a route guard that we want to protect, it could look something like this. We want to verify that the ACR claim from the ID token matches whatever value that we're expecting it to be, such as 2 factors. If that authentication level is met, then continue on the navigation. Otherwise, if it hasn't been met, then we want to have the user sign back in, pass in the required ACR values, and then also keep track of the current URL that they're trying to navigate to. One of the key factors of this spec is that we retry the action that the user is trying to make on their behalf. So we're going to re-navigate back to this URL for the user and return false because we want to prevent navigation for now. All right, so let's see what this looks like in action. I'm going to sign out here so that we start from the very, very beginning. And then in the code, we are going to go to a guard. Now, I already have an auth guard written. It just checks authenticated state. And we'll just slam this code already into the same file. We'll preserve some electrons or something. So we're going to return false at the very end so we can keep that code. And I've also injected the auth service that we could use. And if the auth service is ID tokens ACR claim, which I have a helper method for, just so we can focus on the fun bits, if that equals some value, and for this case, we're going to say 2-factor, and I have a constant define, a string define for it that matches that, that 2-factor any from Okta. So if this is true, then we can return true. Otherwise, we want to have the user sign in. And we can use the auth service again, the auth service again, and log in. And this method will take the ACR value that's required. So here we're going to pass in the ACR value of 2 factors and keep track of the current route they're trying to navigate to, which we can get from the state parameter. And of course, we're defining this in the guard itself, but you can pass the required ACR value as a route data as well. So with that, let's add this to the admin route and see what this might look like. So I'll add the step-up auth guard here. And then let's try logging in. And I have signed in with my password. All right, all good. And if I go to heroes, I can still access it. So I'm signed in. Now, if I go to admin, I should be redirected to Okta to sign back in. And let's see if that works. All right, I wrote this code right. And it's going to send me a push notification this time. So let me accept that. And now that I'm signed in, I'm redirected back to that admin route. And I now have stepped-up authentication guarding that route. And we can check and take a look and make sure that is exactly what happened by looking at the console log and looking at that where it was navigated to. So you can see here I have those URL parameters like we saw before with the client ID. But this time, you'll see a ... and then alius equals Okta URN Okta LOA 2FA any. That alias is supposed to be ACR_values. It's just very long, so Chrome cuts it off, but it's there. And we can verify that it actually is there by taking a look at the token itself, looking at the claims, and you can see that 2FA any is in that ACR claim. All right, I'm going to log back out. So then for this next section, we'll make sure we start from the beginning again. Protecting a route isn't the only thing we could do. As a matter of fact, the main point of this spec is that we're protecting resources. And those resources normally are from making an API call. So you can protect API resources with step-up auth, such as checking that payload value of that large purchase, for example, or making a call to add a new hero. By calling the API then evaluates the ACR claim that's in the access token. And if it doesn't meet the requirement, it's going to send back an error. The client then has to respond to this error by having the user sign back in, using the ACR_values that is appropriate for this action, gets the new tokens, and then remakes that request on behalf of the user back to the API. Right? So when that's, again, that retrying is key. There's going to be a standard error that we're going to get back from any resource server. And that is going to be a 401 unauthorized. And in that www authenticate response header, we're going to see the error of insufficient user authentication. That's the key that tells you that this is a step-up authentication error. The error description is going to say what the requirement is, such as a different level of authentication is required. And it's also going to return back the ACR values that's required for performing this action. And then how do we handle that in Angular? Well, building upon the basic building blocks that we've already talked about, such as the interceptors, and then you might throw in some services and things like that to help react to any API error that we get. In the interceptor, what we'll do is we'll catch the HTTP error and then handle it. We're going to handle it by making sure that that error is a step-up authentication error, and then grab the necessary bits of information from that standard error to get the ACR values into an error format that then we can work with in the rest of the code, because the interceptor is not where we should be having the user redirect for sign-in. We'll handle that ACR values and that error someplace else. And we'll need to first make sure, once again, the error is a step-up authentication error, and then redirect the user to sign in. So this might be a service, it might be a component, wherever you want it to be. And then always re-request the resource. So we're going to try this, and we're going to try this in an interceptor and in a service. So the first thing I'm going to do is I'm going to enable the step-up authentication checks in my API. So I would do that in my Nest.js backend, and I have this defined for the entirety of a hero's route. So obviously, that doesn't quite work if you're trying to do something that's like on a payload check or something like that. But for a demo, this should suffice. So I'm saying anytime we make a call to the hero's route, we require two-factor authentication. Then if we take a look at this middleware, I already brought in all the JOT verifier libraries and things that I might need. And I'm evaluating it, making sure that the access token is valid first. And then if the ACR level isn't met, I'm going to create this error with insufficient user authentication, the error description, and then also the required ACR value, which was the two factors. Then I'll be sending back this in a 401 response and that error code in the response header. So let's go make sure first that this is what we're seeing. If I go to sign in, so I'm going to verify with a password first. All right, so no thank you. If I sign in, let me clear this and then go to hero's route. And I should see the 401, and I do. So if we take a look at the 401 error, you can see that I have that www authenticate error response with the insufficient user authentication, and then the ACR underscore values parameter as any two factors are required for this action. So I think I could stay signed in. And let's just try enabling this in Angular. So on the Angular side, we're going to first use an interceptor. And I've scaffolded a lot out here. Just for a lack of time, I can't type all of this in a 30-minute session. So what I've done already is I've caught the error. I have a catch error handler. I handle this error. I've verified that the HTTP error is a 401, that it's coming from an origin that I'm expecting. And so now what I have to do is ensure that it's a step-up authentication error. So we can do that by looking at the headers. And then we want to get the www authenticate header, which I have a define for already. And that if that includes insufficient user authentication, which I have another define for, then I know for sure that this is a step-up authentication error. And then what I'm going to do is I want to grab that ACR values out of that error response, which I have a utility method to help me do so. And I also want to grab the insufficient user authentication error out as well, so I can use that as a flag for later on in the Angular code. So now the next thing we want to do is we want to respond to this, and we're going to do so in the hero service, where I make the call. I have another catch error here. I'm making sure that that error type is an insufficient authentication error and not like a 404 or something. And then so here is where I'm going to request authentication. Now I've injected the auth service. So I can use the auth service and log in and pass in the required ACR values, which I grabbed from the message field here on this error. And I'm just turning this into an error format that Angular can also handle, is what I'm doing, and just cheating off of that. And then thinking of cheating, I'm going to cheat another way, because we're in a demo scenario. I need to retry this action on the user's behalf. Now, for me, I have this call to get the heroes upon component initialization of navigating to the hero's route. So I just have to re-navigate them to the route, and I'm good. I retry the action for the user. Clearly, in real-world scenarios, that's not going to fly. So you will have to add more nuanced handling for retrying on the user's behalf. So I'm going to just pass in the current URL, which I've already grabbed from the router state snapshot. And this should be good to go. We make sure that I add this interceptor, though, to the application. I keep forgetting this step. All right, let's see if this works. So I'm already logged in, and I've only authenticated with the username password. So now, if I go to the heroes route, I'll see that 401 navigated back to get my second factor, which is a push notification for me. I accept it, and now I get the list of heroes. So it's retried that action on my behalf. So if you want to see this code for yourself, try it out, play with it. I do have this in my GitHub repo. You can start with the main, and main will be where we started today, and completed branch has all the completed code. And as I said, I've already brought in Okta, I've already brought in all your configurations, so you don't need to deal with any of that. It should work almost out of the box. You might be wondering, what about authentication recency? Isn't that a core part of that spec? And you're right, it is. We focus on authentication levels in this demo because counting time seems to be not the right way to spend demo time, right? So how we would normally handle authentication recency to make sure that the user has authenticated recently before performing an action is very similar. You're still going to have a 401 unauthorized error, and you're still going to get that insufficient user authentication error. The error description changes, though, saying that a more recent authentication is required, and then you're going to get back max_age of some value. So every place where you used, or we used, ACR_ values, replace it with max_age. Any place where we use the ACR claim, replace it with auth_time. And that's how you would do your time calculation to determine if the authentication recency is up to snuff. And then you may also be wondering, well, this is fantastic, but what about access control measures? Isn't this what the whole point of making sure that that user has the authority to do? I mean, like, what's up with that? Well, keep in mind we're looking at two different things here. One is ensuring that the user has the authority to perform that action. That's access control. Well, what we're checking here is to ensure that the user is who they say they are, right? That we have that identity assurances. So these are two different things that combined together will complement each other really well to have better protection of our resources. And then lastly, I will have to point this out because we used passwords, and I had some really not great passwords enabled for this application, is you always want to start off with a good authentication security as a foundation. You want to try to use phishing-resistant factors if you can, right? You want to ensure that you're starting off at a good authentication foundation and building upon there. So in that Okta configuration that I built, I do have things enabled for PHR or PHRH if you want to try those factors and some higher authentication levels. All right, so if you'd like to learn more, I have these slides available and this QR code, so you can come back and refer to this. You can grab the repos. You can also check out a tutorial I wrote, basically this whole project from this ground up, using step-up authentication on an Angular app and Nest.js backend, and I have a link for that. And if you are so inclined, feel free to check out the spec. It's actually a pretty good read for, as far as specs are concerned. And feel free to reach out to me on the socials at Alisa Duncan if you have any questions, you want to chat about auth, security, access management, anything like that. Honestly, traveling, K-dramas. I love talking to NG friends. And I also brought some Star Wars-themed stickers and some Halloween candy from the US. They'd be happy to meet and chat and hand it out to you. Feel free to find me after this talk or go out and check out the Auth0 booth, because I'll drop some off there too. Thank you very much.